When you heat something, maybe you put it in a pan on the stove and you turn on the burner, it gets hotter, right? It warms up. All substances will change temperature when they're heated, but how much they change will vary. You think about a plate of food at a restaurant, and maybe you've got a steak, and you've got a baked potato, and you've got a big piece of Texas toast, right? And it all comes out, and it's all hot to start with. Which one stays hot the longest? The steak, the potato, or the toast? The potato. Hot potatoes stay hot for a long, long time. And they're full of water, yeah. The toast is going to cool off the fastest. And there's a reason behind that. It has to do with the heat capacity of the substance. The baked potato has a lot of water in it, and water has a very high heat capacity. Heat capacity is the amount of heat that's needed to change the temperature of a particular amount of substance by 1 degree Celsius. What we usually use is called the specific heat capacity. Sometimes we just call it specific heat. And that's the amount of heat needed to change the temperature of 1 gram of a substance by 1 degree Celsius. So this is going to have these funky looking units, joules per gram degree Celsius. How many joules for every gram and degree Celsius are needed? That's the specific heat of a substance. Water has a very high specific heat capacity. Here's a table from your textbook. Water's down here. 4.184 joules are required to heat 1 gram of water 1 degree. So if it was 25 degrees Celsius and you wanted it to be 26 degrees Celsius, it would take 4 joules to do that. If you had lead, and you had 1 gram of lead and you were trying to make it change the same temperature, you'd only need 0.128 joules. Lead has a low specific heat. Most of the things in here are metals, right? Metals have low specific heats. They change temperature very easily. Water does not. Ethanol here is kind of in the middle. So when you're doing homework problems, you may need to refer to this table. They may not give you these specific heats, and you just need to go look them up. On an exam, they will be provided either in the question or in a little table at the beginning of the exam. You do not need to memorize specific heats. Let's think about summer in San Francisco versus summer in Fresno, California. The average high temperature in August in San Francisco is 66 degrees. What? That's crazy. In Fresno, the average is 96, 30 degrees higher. Now, it's not like San Francisco is like by the North Pole or something. You know, we're roughly the same distance from the equator. That affects temperature. Why is Fresno so much hotter? It's land versus water. San Francisco is surrounded by water, literally. It's on a peninsula. It's got the ocean on the west coast and then the bay on the north and the east side of it. It's surrounded by water. Water has a very high specific heat. So where does the heat in the day come from? It comes from the sun, right? So the sun beats down and it hits the land and people and buildings and trees and water. The water doesn't heat up very much. It absorbs the energy from the sun and only warms up a tiny bit. And then at night, when the sun goes down and that heat source is gone, now the air is cooler than the water, and the water releases heat back into the surroundings. That big body of water around San Francisco moderates its temperature. The average temperature in San Francisco, summer and winter, is very, very similar. It's almost colder there in the summer than it is in the winter. Not true here. In Fresno, we have very little water. Even the ground is dry, right? So the sun comes down, because basically we're living in a desert. The sun comes down and it hits dry things that have lower specific heats. They heat up quickly. And then when the sun goes down and the source of heat is gone, they cool down quickly too. we have low humidity in the air. And so as soon as that sun goes down below the trees, you can just feel it cooling off, can't you? I grew up in the Midwest where they have very high humidity, like 90% humidity. And the sun goes down and there's enough hot water in the air that it just does not cool down like it does here. You might have a 10-degree temperature difference. And I know this morning it was like 60 degrees outside at my house, and it's supposed to be 96 this afternoon. And so we get these huge temperature fluctuations because of the lack of moisture in our environment. I think that's interesting.